Hello. Today's lecture will cover the material from Chapter 12. Chapter 12, Testing for Equality of Three or More Population Proportions. Recall from Chapter 10, we used the z-test to test the difference in two proportions. And the question is, what if we have more than two proportions, say 3 or more proportions? And in here, we introduce the chi-square test. Chi-square test for testing the equality of population proportions for 3 or more populations. Please keep in mind we use this so-called 3-step procedures to test the hypothesis. Step number 1, state H0 versus H1. Step number 2, find the test statistic. And step number 3, make a decision using either the p-value approach or the critical value approach. So in here, we first state a pair of hypotheses. H1, not all population proportions are equal, versus H0, P1 equal to P2 equal to P3 all the way to Pk. K is the number of populations or number of proportions. And step number 2, we find the test statistic chi-square using equation 12.5. And the test statistic chi-square is equal to this double sum of Fij minus Eij square over Eij, where Fij is the observed frequency or given frequency for the cell in row I and column J. Eij is the expected frequency for the cell in row I and column J under the assumption F0 is true. Therefore, if we know how to compute Fij, Eij, then we'll be able to use this formula to compute the test statistic chi-square. We will find the observed frequencies Fij from a given table called the sample result table, and select a random sample from each of the populations and record the observed frequency Fij in a table, say with 2 rows and k columns. Then this sample result table will look like this. And row number 1, you have some values recorded into this table, and you have a subtotal for row 1. And then for row number 2, you record all the values and you get another subtotal for row 2. And then this is the column total for column 1, column 2, etc. And your observed frequency for row 1, column 1 will be F11, and this will be F12, and then this value will be F1k. For the expected frequency, you have this equation Eij equal to row I total times column J total over total sample size. Say we are interested in calculating E11, then you will have row 1 total, this is a subtotal, times this column 1 total, this is the subtotal, over the grand total. And here's how you calculate E11. So row 1 total times column 1 total over the grand total. to compute chi-square, the test statistic, we will set up a table to do so. And here's how we will set up the table. You have Fij, the observed frequency, and then you have this Eij, the expected frequency, and you're going to find Fij for each cell, and then you're going to compute Eij for each cell, and then you use the equation Fij minus Eij square over Eij for each of the cell, and then you sum them up, and that will give you this test statistic, or set the chi-square. Step 3, make a decision. To make a decision, we first introduce the chi-square table. The test statistic had chi-square distribution with k-1 degrees of freedom, and k is the number of proportions or populations. Alpha is the level of significance. For the chi-square test, we only use the upper tail test or the right tail test. And here is the chi-square table with alpha's level of significance of 0.10, 0.05, 0.025, 0.01, and 0.005. And say for testing 3 proportions, then the degrees of freedom will be k-1, which is 2, and we are going to use this set of data for the critical value of chi-square alpha, and with alpha equal to 0.1, then chi-square alpha will be 4.605. For chi-square alpha with alpha equal to 0.05, with degrees of freedom of 2, you will get 5.991, etc. We can use either the p-value approach or the critical value approach to make a decision. So for the p-value method or p-value approach, we reject F0 if p-value is less than or equal to alpha. Keep in mind this is an area versus another area, or you said that is the probability versus another probability. When we use the critical value method, it's a point versus a point on your x-axis. Because this is a right-tail test, so we reject F0 if the test statistic is greater than or equal to the critical value chi-square alpha. Now, let's look at an example. Suppose that in a particular study, we want to compare the customer loyalty for 3 cars: Chevy, Impala, Ford Fusion, and Honda Accord. The hypotheses are stated as follows. H1, not all population proportions are equal. H0, P1 equals to P2 equals to P3. So keep in mind, K is 3. So you have 3 populations or 3 proportions. Here's the sample result table. Likely to repurchase, you have yes for Chevy 69, for Ford 120, for Honda 123, and the subtotal for yes is 312, for Chevy for no is 56, Ford 80, Honda 53, and the subtotal for no is 188. And then for Chevy, a subtotal of 120, Ford subtotal of 200, and Honda subtotal of 175, and the grand total is 500. Now, we need to find the test statistic and use alpha equal to 0.01 to make a decision. So we already have step number 1 and step number 2. We set up a table to find the test statistic. And we are using equation 12.5, which is the double sum of Fij minus Eij square over Eij. So we set up this table with the observed frequency Fij to be 69, 120, 123, 56, 80, and 52. That's from this sample result table. And now we need to compute the expected frequency Eij. So associated with this F11, this 69, this location is F11, you have subtotal of 312 and subtotal of 125 and grand total of 500. So you have 312 times 125 over 500 to give you 78. And for 120, and you have subtotal of 312, subtotal of 200, and grand total of 500. So you have 312 times 200 over 500 to give you 124.8. For 123, you have 312 as the subtotal, and then another subtotal over the grand total. So you have this 312 times 175 over 500 equal to 109.2. And then for 56, you have 188 times 125 over 500. So you have 188 times 125 over 500 to give you 47. And then you have for 80, you have 188, 200, and 500. So you have 188 times 200 over 500 to give you 75.2. And then the last one, you have 188, 175, and 500. So you have 188 times 175 over 500 to give you 65.8. Now you compute Fij minus Eij square over Eij. So you have 69 minus 78 square over 78 to give you 1.0385. And then you have 120 minus 124.8 square over 124.8 to give you 0.1846. And then you have 123 minus 109.2 square over 109.2 to give you 1.744. And the next one, you have 56 minus 47 square over 47 to give you 1.7234. And then you have 80 minus 75.2 square over 75.2 to give you 0.3064. The last one, you have 52 minus 65.8 square over 65.8 equal to 2.8942. And then you add them up. This will be your chi-square or your test statistic. And in this case, This is 7.8911. Step 3. Make a decision using either the p-value approach or the critical value approach. Now, when we use the p-value approach to make a decision, we need to find the probability range associated with this chi-square table. So keep in mind the degrees of freedom k minus 1 is 3 minus 1 equals to 2 because we have 3 proportions, or we said we have 3 populations. Now, your test statistic chi-square is equal to 7.8911, which is between 7.378 and 9.210. So your probability range associated with your p-value will be between 0.01 to 0.025, which is greater than alpha equal to 0.01. So we failed to reject F0. Not enough evidence to conclude the proportions of customer who's likely to repurchase are different. And that's our concluding remark. So if we use the critical value approach to make a decision, we have a point versus another point. So we use the critical value versus the test statistic. And the critical value chi-square alpha is equal to chi-square 0.01, which is 9.210. So we draw the number line, put the 0 in the middle, and you have the critical value to be 9.210, and your test statistic is 7.891, which is less than the critical value on the right. We failed to reject F0. And again, if you use the p-value approach or the critical value approach, you should draw the same conclusion. And in this case, you failed to reject H0.